Hey, how's it going guys? JP here. Today's video, we are going to be solving LeetCode question number 1 to sum. So before I get started, if you guys do enjoy these type of videos where I solve LeetCode questions or you like programming content on YouTube, leave a like on the video as well as sub to the channel. And yeah, that's about it. Okay, so let's get started with the question. In this question, we're given two things. We're given an integer array or an integer array called nums as well as an integer called target. Now, what we need to return here is the indices of the two numbers that sum to the target. Here we can also assume that there's going to be exactly one solution and we cannot use the same element twice. Now I'm going to cover what that means, what it means when we cannot use the same element twice. So let's just say, for example, we had an input array of something like this, right? We had 2, 3, and 4. And let's say our target here is equal to 6. So it's clear that we can make the number 6, right? If you use this number 3 twice, right, we can just return 1 and 1, right? Because this 3 is an index 1. But of course, we cannot use the same element twice, so we can't say 1, 1. However, let's just say instead of 4 here, we have 3. Well, 3 is also here. So that means we can return 1 and 2, right? So basically, if the number appears more than once, then we can use that number, that many times. So that's what it means by we cannot use the same element twice. Okay. So now that we have that out of the way, let's actually talk about some of the examples so that we have a better understanding of what we need to return given a certain input. So starting off with example number 1, we're given this array of numbers of 2, 7, 11, and 15, and here our target is 9. Okay, but it's pretty obvious that the first two numbers, 2 and 7, will sum up to 9, and that's why we return 0 and 1. If we take a look at example number 2, we see that the last two elements, so index 1 and 2, return, or not return, but sum up to 6, right? So 2 and 4 equals 6, and those two numbers are in positions 1 and 2 respectively. So, it's pretty easy to understand what this question is asking. But now we need to figure out, well, how do we solve this question? A pretty intuitive solution would just to calculate all of the sums of the numbers, right? So all the combinations, and we get their sums. So what I mean is, okay, well, if we go to example number 1, we can start with number 2, and we could start looping through all the other numbers until we find the target. Now, if we were to do that, the worst case scenario is that the last two numbers will be our solution. And as a result, we're going to visit each of the numbers at least twice, and that will result in a runtime of big O events squared. And if you're familiar with the big O notation, you know that that is not efficient at all. So let's think of another way of solving this question. So in the first solution, we didn't use any data structures. So in this solution, we are. Let's start using something called a hash map, or in Python, it's called a dictionary. Basically, what that means is that we're going to have a value, and that's going to map to another value. And all the values that serve as keys will be unique. So what does that, what does that mean? Or how does that work in this context? Well, basically what we could do is we can have, we can iterate through the array. And what we can calculate is the complementary number needed in order to create the target number, given that we are at index, index I. So to better illustrate that, let's actually go through example number 1. So here I'm going to just write out the index that we're currently on, as well as the number in that index, and then also the complementary number needed in order to sum the target, right? In order to get the target. So first off, we're going to start at index 0. At index 0, we have the number 2. And then the complementary number is basically the target, which is 9 in this case, minus the number that we're currently on. And that's going to be 7. So what this means is that we're going to look for the number 7 in our nums array, and then we're going to map that to the index of the complementary number that is needed for number 7. So in other words, right, if we had 7 in our array, right, we would need to refer to index number 0, which gives us the number 2. And then what we could do is we could just return that index, so the complementary number index, and we can also return the current index that we're on. So basically, if we do this solution for example number 2, I think it'll better illustrate it. So let's do that. Okay, so I'm just going to erase this real quick, and I'm going to start off with 3. Okay, so at index number 0, we have number 3. Our complementary is 3 as well, right? So 6 minus 3 equals 3. So we can map 3 to its complementary number, which is 0, or not number, not the index of the complementary number of 0. And you can see that every time we iterate, this dictionary is going to keep track of what number do we need in order to get our target. So if you go on to the next number, right, we have 2. So we do the same thing. We say, okay, our index number 1, we have the number 2, and our complementary number given we have 2 is 4, right? So 6 minus 2 is 4. So we can map out the 4 to our index 1. And then finally, we go to our last number, 4, and we ask ourselves, wait, we have 4, or that's not a really nice looking 4, but we have 4 in our dictionary. So let's just return our current index and the index of the complementary number given that we have 4, which is 1. So we have 1, and then the current index, which is 2. And then we can return 2. So you can see how that works. And you can actually see that we're only going to iterate through the nums array only once, meaning that it's going to have a runtime of big O of n squared, or not big O of n squared. It's going to have a runtime of big O of n, right? So linear time. In terms of space complexity, it's also going to have a worst case scenario of big O of n. So yeah, that's basically the solution. Now let's actually code it up. Okay, so let's move on to the code. Okay, so the first thing we're going to need is the dictionary or the hash map. So I'm just going to call it hash map, and it's going to be an empty initially, right? It's going to be empty. And then what we're going to do is we're going to enumerate through the nums array. So for I and num in enumerate our nums, right? So just a quick, for those that don't know what enumerate does, basically it gives us, as we loop through the array or the list, it gives us the index that we're currently on and then the number at that index. So for example, if we had something like in the first example, something like this, then our I, right, I will give us the index, which is 0, and then the number at that index, which is 2. So it'll give us both of these values every time we loop through each of the numbers. Okay, so what I'm going to do is I'm going to create a variable called difference. I'm basically going to calculate the difference, and the difference is going to be the target minus our number. Okay, and what we need to do is we need to check two things, right? We need to check whether or not that number that we're currently on is in our hash map, right? Because if it's in our hash map, that means we can return the two values that make up the target. So we check that. Okay, if the number is in our hash map, then we can just return the value, right? The index of the previous number, right? So in this case, it will be our hash map and then the number. And then we also need to return the current index that we're on. Now, if that's not the case, what we need to do is we need to record that number in our hash map. So we say hash map, then our key will be the difference, and then that will equal the index that we're on. Okay, And since we already know that there's going to be a solution, we don't have to do anything. But just in case if there was no solution, then we can just return a -1 if there was no solution. But otherwise, since there is, it's going to return those two numbers or those two indices that have the numbers that sum to our target. So let's run the code. There you go. So you can see that it passed the first example, but now let's see whether or not it will pass the all the tests on LeetCode. And there we go. So you can see it's pretty efficient. It runs here. I mean, this doesn't really matter too much, but this is a pretty efficient solution. And yeah, that's about it. All right, hope you guys learned something. Again, if you guys do enjoy these type of videos where I solve LeetCode questions, sub to the channel, as well like the video. And if you have any suggestions, leave a comment below. All right, later.